going to look at the second derivative test for extrema. So this is still section 3.4, but it'll be day 2. So continued on from yesterday. All right, so we're going to look at the second derivative test. For extrema. Okay, so this is your relative max and min. Alright, so we're going to use this test. And this is just another test. We had the first derivative test for relative max and min, and this test also can be used for relative max and min. So use this test for a critical point at x equals c to determine relative extrema. Okay, so what we can say is if f double prime of c is greater than 0, so concave up, then f of x has a relative. If you think about it, if it's concave up, that means the graph is facing up. It's going to be a relative minimum at x equals c. Okay. We can also say if f double prime of c is less than 0, then f of x has a relative maximum at x equals c, which should make sense because the graph would be concave down. The third statement is if f double prime of c equals 0 or undefined, okay, then you must go back to use the first derivative test. So if you look at an example with me, I'm going to say use the second derivative test to determine relative extrema. Okay, so our function is going to be f of x equals x to the 4th minus 4x cubed. Alright, so first of all, we need to find our critical numbers. So I'm going to need to find my first derivative. Okay, set it equal to 0. Factor out of 4x squared. So my critical numbers are going to be when x equals 0 and x equals 3. Next, I'm going to find my second derivative. Okay. And I'm going to use a second derivative test, so I'm going to evaluate my second derivative at 0. Well, I end up getting 0 out, so that means I need to go back to my first derivative test. Negative infinity to 0, and then 0, and actually just up to 3 because that would be my next critical number. So now I have a 0 there. If I go back to my first derivative, I can see that if I plugged in, let's say, negative 1, I'm going to get a negative out. If I plugged in, say maybe 2 between 0 and 3, if I plugged in 2, I'm still going to get a negative out. So there's still no change in sign, so there's no relative extrema. and plug in my other critical number to my second derivative. And this is going to end up giving me a number greater than 0 if you work through it. So then I can make a concluding statement. Since f double prime of 3 is greater than 0, f of x has a relative, and remember if it's greater than 0, that means it would have been concave up, so a relative minimum at x equals 3. Okay. Hopefully that should help you out with things for section 3.4.